Good afternoon, everyone. We are here honored to have Lima Agnel Tony, an engineer from the Indian Space Research Organization, talking about building a standalone AI assistant for deep space exploration. We're happy to have you. Please remember to write down your questions in the chat box so we can read them at the end of the presentation. Don't be shy and enjoy.
Thank you so much, Anna. So, hello everyone. Today I will be presenting on building a standalone AI assistant for deep space exploration. This is a work by my team, and my team includes Dr. Harikumar Ganeshan, Sangeeta GR, Amrita A, Dureraj R, Joji J. Chaman, and Padmakumar S. ISRO has a vision of sending humans to space, like all spacefaring nations. However, there are a lot of challenges involved, as all of us would know. Safety is, of course, the prime factor because sending humans to space, life is important. But there is another aspect to which once the humans are on space or on orbit, what about their mental wellness? So, this is because there are a lot of challenges involved. The first one being that any space mission is a long duration one. We know that sending somebody to orbit and staying there for a considerable amount of time, the whole business takes time. The second aspect is that once the astronauts go to space or once they are on orbit, there are a host of routine events which the astronauts are supposed to do. So doing the same thing every day creates boredom. And another aspect is the whole life in space or on orbit is monotonous and harsh in comparison to what is on Earth. So all these things create a mental tension or mental stress for the astronauts. So having a support system there on orbit is quintessential for any astronaut to have a good quality of mind. So there has been a lot of robotic companions that has been developed by many spacefaring nations across the globe. So we will quickly go through which are these. First one is AER CAM Sprint. It stands for Autonomous Extravehicular Activity Robotic Camera, and its name is Sprint. This was deployed by NASA. And as you can see, it is an oversized football and it has two cameras. So this was predominantly meant for extravehicular activities, meaning outside the vehicle. So it used to document what was happening or telecast what was happening outside the vehicle, and the operator would be inside. And the next one is a cute little robotic companion, which probably would have connected so much with the astronauts. So its name is INT ball. This is a Japanese experiment module, and INT stands for internal ball camera. So as of 2024, two versions of this has been deployed in ISS. And the main functionality of INT ball is to document what is happening in ISS. And the next one is spheres. Sphere stands for Synchronized Position Hold Engage and Reorient Experimental Satellite. So as its name suggests, it's a satellite, meaning in comparison to all the robotic companions we just discussed, this is more of a testbed come companion, meaning this was a platform used by astronauts to test and validate several algorithms for rendezvous, docking, etc. And this is a more recent and interesting astronaut or robotic companion. Its name is Astrobi. This was deployed by NASA in 2019. There were a triplet of Astrobis deployed in ISS, and they were even called by names like Bumble, Honey, Queen, etc. So by mentioning their names, I would like to stress to the fact that astronauts try to connect to these kind of machines, even though they are machines, and build some companionship by calling them name or whatever possible. So this had a major feature upgrade that it was able to perch, it was able to fly around, it was able to carry cargo for the astronauts, at the same time do documentation, help in microgravity experiments, etc. And the last one is Simon. Simon stands for Crew Interactive Mobile Companion. And this was an initiative by Airbus and IBM. And it was deployed in 2016 as well as 2019. So as you can see in the figure to your left, it has a display. And on the display, you can see a simulated face. So to the need of connecting with the humans on space, or the aspect of mental well-being by companionship, was a little more relevant by the time Simon was deployed, because of which such a phase was also integrated to the AI robot. So coming mention just that, and just now I mentioned that it's AI robot. So this is the first robotic companion in ISS which was AI enabled. So it had natural language processing on board, and Simon is known to be a stress reducer for astronauts because it was able to strike good conversations in a very human level with the astronauts. So, like all these robotic companions, or all these robotic companions point to the fact that there is a requirement of some human or non-human component in space, which would be able to provide a support system for the astronauts. But some of the aspects which have to be considered while designing such systems would be: it should be power optimal, it should be able to emotionally connect with the astronaut, it should be able to locally operate and be portable as well. So, coming to Indian Space Research Organization's perspectives, as I mentioned before, we do plan to send humans to space, and these are the most relevant missions in that regard. The first one is Gaganyaan mission, which plans to send humans to space, and it has its unmanned counterpart as well. The first one will be the unmanned counterpart, in which a half humanoid robot will be sent to space, and in the subsequent missions, humans will be sent to space as well. And the second mission would be the Bharatiya Antariksha Station, or the Indian Orbital Space Station, which is the Indian variant of the ISS, which will be flying around carrying Indian astronauts so that they could perform microgravity experiments and all other developments and many good things. So, because we are also planning to send humans to space and we would like to take care of the mental well being of the astronauts on board, ISRO is also thinking about developing an AI companion board. And in process, we developed Chandra, which is ISRO's AI voice assistant. And Chandra, the word Chandra would mean moon. Okay. So some of the features of the AI voice bot are, the first one is it is enabled with the state of the art large language model. We all know what is a large language model. We are all familiar with ChatGPT, the generative pre-trained transformer. It's something like the state of the art chatting infrastructure that we all are using. So at ISRO, we were able to integrate the large language model into our AI voice assistant, and it has bilingual support, and it has a simulated face for emoting what is being spoken. And as we had heard in one of the morning sessions, the space environment is unforgiving when it comes to memory devices, electronic modules, etc. So there is a need to ruggedize systems before sending them to space. So here at ISRO, we have ruggedized certain processors and electronic components. And here we have used an edge device, which is a CPU GPU combination. And we have deployed the AI voice bot on the same. And we do not require, or the AI's voice bot does not require any cloud support or internet connectivity to function. And it uses optimal power. And some of the major functionalities of this AI voice bot are: it is able to chat with the astronauts, make conversations. Then it will be able to support onboard experiments, whether it is by helping them or guiding them through the experiment, or taking notes while doing the experiment, or video documenting the experiments. All these things can be done. And it also contributes to the leisure aspect of the astronaut, like playing music, videos, etc. So in this talk, I will be primarily focusing on the software and the hardware design of Chandra, and along with some performance results of the same. So first, let us go through the software aspects of Chandra. So to the right of your screen, what you're seeing is the block schematic, which is a simplified block schematic, which represents the software of Chandra. So coming to think about developing any device per se, the first part would be to have some design ideas on a block schematic level. So everything starts from that drawing board. So this is what that is. And to the left, you can see the major elements listed. The first one being the speech preprocessing, which we will look into now. So speech preprocessing involves three major aspects. The first one is VAD, second is KS, and the third is ASR. VAD stands for voice activity detection. So when we speak, there's a host of frequencies which will correspond to noise as well as the speech signal. The objective of having a voice activity detection module is to filter out the noise in some sense and just allow only the speech frequencies. That is the first module. The second one is keyword spotter. Keyword spotter is a quite familiar component of all our household. Say, for instance, we do Hey Siri or Alexa. These are the names with which we call all the AI devices around us. So those words are the keywords. So in all those machines, there lies a module called keyword spotter, which gets triggered whenever that particular keyword word is spoken to. So here also we have a keyword, which is Chandra, its name itself. So whenever the word Chandra is spoken, the keyword spotter triggers the automatic speech recognition. So automatic speech recognition is the heart of the pre-processing system, which takes in the all pre-processed speech signal and converts that into its text equivalent. So here we have two versions of that, or two variants of that, English as well as Hindi. So a brief description of what the automatic speech recognition module is. We have conceived a hybrid approach for ASR, in which we have used the Kaldi-based time delay neural network for ASR model, and it supports Indic English. Not in order to take care of the Indian accents, we have Indic English as well as Hindi languages, which are supported by the ASR, and it has been trained on 50 hours of data with 40,000 unique words. And the next important aspect is the QA manager. Now we are here, which is the QA manager. So QA manager stands for question answer manager. As I had mentioned in one of the first few slides, the chatbot or the AI voice bot has a spectrum of functionalities. It can make conversations, at the same time, it can play music also. So there should be some discretion between two, or it should be classified at some point whether it is a conversational speech coming in or a command speech coming in. So the QA manager does that bifurcation. And if it is a conversation kind of speech coming in, it will be channeled to the chatbot. While if there is a command aspect to it, then it will be sent to the operations assistant, which will take care of the rest of the things, like attending to the command. So if the commands are going to operational assistant and the rest of the chat is sent by the QA manager to the chatbot. So chatbot is the next major module. So as I mentioned before, we are using a large language model based chatbot, and we have three variants associated with it. So the large language model that we are using is Vicuna V1.5, which is a 7 billion model. So why 7 billion model? We all know that larger the model, more the accuracy. But then because of the hardware constraints, we have considered and we have taken a 7 billion model, but it is performing to our satisfaction. So this is a Llama 2 fine-tuned model, and it is served using an open source platform, which is called FastChat. We have repurposed and ROS integrated the code stack for our disposal. So we have three variants. How do we decide which variant we should use? It's based on application. So we will quickly go through each of these variants. The first variant is large language model itself. So it's a token generator, meaning it's a text generator. So there are certain pros and cons associated with it. First one is the advantage is that in comparison to any rule-based chatbots, A large language model is able to answer to a wide variety of questions or wide variety of topics. But the other side is that the LLM may sometimes hallucinate, which is a very known problem. And in addition to that, if it is trained on a particular set of data and we want to add some custom data to it, is quite difficult unless we retrain it. So that is the difficult part of it, because training a large language model is not a cheap business. It is a very expensive one. And on top of this, when running a large language model, we see that it takes time as well. So this give rise to the second chatbot model, which is another state of the art, well celebrated retrieval augmented generation model. So the block schematic briefly explains what RAG chatbot is. So here what we have is we have a VD, which is a vectorized database, and which collects all the raw data from us. So whenever a question comes in, the question is first sent to the vector database, and the most similar data associated with the question is picked up from the vector database by the retrieval model. And this is appended, which is done by the context generator. The question as well as the retrieved data is appended together and sent to the large language model. So the large language model essentially here has a context with which it can answer to the questions in a better way. So here, promisingly, the text generation is based on retrieved information and more accurate responses happen because the large language model has a context to it. And the additional advantage is that we will be able to add custom database which are without much issue, without retraining the large language model. And the third part is LLM as an advisor. So when we have a very large chunk of data or text going into the large language model, it may be difficult for the LLM to process it in a very fast manner. So why not ask the large language model only when it is needed? So that idea gave rise to this third variant of the chatbot. Here, what it does is we have a super fast retrieval chatbot. So this is a bare Python implementation of a retrieval chatbot in which we will be able to get responses in the order of milliseconds. And whenever we have, say for instance, we have some information, custom information about Indian Space Research Organization, we would be training the retrieval chatbot for all those things. So whenever a question comes which is outside this particular domain, then only the LLM will be consulted because LLM is an advisor. For all other reasons, all other questions, the retrieval chatbot works, because of which the whole pipeline speeds up to a couple of orders better. Yes. So the next aspect is text to speech conversion module. So now that thinking about the speech pipeline, we had a speech or a query, we have got the answer to that, and now we have to voice that answer, which is done by the text to speech conversion module. So here we are using an open source model, which is the AI for Bharat Deep Neural Network model. It's a single model which supports both English as well as Hindi, Indic English and Hindi. And we have chosen a female voice for Chandra. And the last important major module is graphics management. So as I mentioned before, it has a face, and whenever the text comes out as speech, the face should be able to lip sync and synchronize, start and stop at the same time the speech comes out. This is taken care by the graphics manager. Now coming to the hardware configuration, what you can see to your right is the product form of Chandra. There you can see the face of Chandra, and this is the hardware module, rest of it. And inside it is what is seen to your left. We have the ruggedized Jetson AGX, NVIDIA Jetson AGX Xavier Industrial CPU GPU combination and its carrier board. And we have speaker mic system as well as a display. So now that we have gone through the software as well as hardware aspects of the AI voice bot, we will quickly go through some performance evaluations that were conducted here at ISRO and the results we have got. So the performance evaluation was done in two levels. The first one was module level, the second one was integrated level. So module level involved testing each modules, the speech modules, essentially the ASR, the chatbot, as well as the TTS. So for that, we have picked 9 candidates, which included an assortment of male, female with different voice characteristics, age group, etc. And for ASR evaluation, there are 2 metrics involved. The first one is word error rate. The second one is real time factor. Both of these are very popular matrices, the definition of which is given below. And following the popular or commonly used benchmarks, we would like to have WER between 5 to 20 and the speed of response, the real time factor, to be less than 1. And when it comes to the chatbot, we have used the 2 matrices, the GP utilization as well as LLM as a judge. So GP utilization implies what is the speed with which it can generate, the system can generate each token. But this is also a hardware dependent. What kind of GPU we are choosing, those kind of things also matter. So we are to be having a trade-off between the hardware choice and the speed of the token generation speed that is there. The second one is LLM as a judge. So this is another popular method of investigating or testing the response quality of an LLM, in which the responses, the queries as well as responses of an LLM will be fed into GPT and requested to rate it upon 10. And we would like to have the rating at least 7. And as far as the text to speech conversion module is concerned, it has the MO score, which is the mean opinion score. Candidates are requested to evaluate the speech signals coming out, the voice coming out, for its comprehensibility, naturalness, and listening effort, and the average values taken. So the quick results here showed that all these 3 modules or the modular level test were giving very promising results, and our effort towards developing those were successful. So in the next level, the integrated functionality test. Each of these modules were put together and how they perform in sync with each other. So for this, we have considered another 10 candidates. And those people were requested to rate the voice bot for its speed of response, relevance of answers, emotional connect, domain expertise and brevity of answers, and overall impression. So to the right, the bar chart gives what sort of questions that the 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 10 candidates asked the chatbot or the AI voice bot. So we had we had we had requested them to ask some specific things. For instance, we had given them some experiments which the database of the chatbot was having. So that was the experiment related. Then space domain related, obviously, being an ISRO chatbot, it should be able to answer something related to the Indian Space Research Organization, and space domain related, that is space related. Then music playback and video playback corresponds to the leisure side of the voice assistant. Then reminder noting is another functionality which was being tested by the candidates. And people were also curious enough to ask generic questions in order to see whether to what level they will be able to connect with the chatbot or the AI voice bot. And we really got some very interesting observations from the responses of the candidates. So as you can see to the chart to your right, there was a mix of responses. Some people felt that the emotional connect was not that much, while a major group felt that the emotional connect was good and they were able to talk nicely with the AI voice bot. So on an average, the responses seem promising, but also there is room for improvement. That's what we could understand. But in conclusion, we felt that the AI voice bot is performing well, both in the modular level as well as in the integrated level. So coming to the next version of AI voice bot, which we are currently working, these are a couple of things we are looking into at this point of time. So the first one is we realized that once this AI voice bot is deployed at the Bharati Antariksh station, there are a host of machines and other equipments which are going to generate noise. And these noise are expected to interfere with the quality of the or the quality of performance of the automatic speech recognition. So what can be done in the pre-processing side to take care of that? That is one aspect which we are currently looking into. The second thing is inclusion of eyes, meaning camera. So as we all would know, adding a camera, adding vision to the voice assistant would make it a complete package in the sense that the addition of vision would provide a spectrum of possibilities to improve its functionalities. The third one is interface to onboard system database. Because we are having a GPU CPU combination, we would be able to, meaning the AI voice assistant would be able to do a host of other data analysis tasks as well. And a huge amount of data will be available at the onboard system database. So having having a link with that would be good. And at the same time, the voice assistant should be capable of taking the data and processing it at some level. And the last one, but not the least, is using sparse language model or small language model. Currently, we have flooded or used the maximum capability of our AI voice assistant, but we would like to use small language models, which are the newest or the latest ones, so that we could save some space and try out some multimodal AIs on space. So as I conclude, I would like to acknowledge all the members of the RAIG, Robotics and AI Group, and all members of ISRO Inertial Systems Unit for their support towards data generation, testing and evaluation and realization of this AI voice bot. So these are a few references, and thank you. And that's from my side. Back to you, Anne.
Thank you very much for your presentation. It was very interesting.
You're
Are
welcome.
there any questions? If not, just remind you that the conference will be stored in our platform and people can contact you afterwards when they watch this video. So thank you very much to our presenter and to our audience. I hope you had enjoyed and keep on attending the rest of the events of the conference. Thanks a lot.
Thank you so much.
Thank you. Have a good day.